Hello guys, welcome back to Math Zone African Motives, still on Mathematics and 4. In this platform, we shall be focusing on integration. So there's a nice question that we have on integration from the question paper of August 2021. So we are not going to waste much time. We are going to quickly rush through the questions that we are given. So the first part was for us to integrate, that's 1.1. I've got 7 marks to integrate each and every term that we're given. So not waste much time, let us just rewrite this so that we can properly see what we are being given to integrate. Okay, this is too much. Let's just try and reduce a little bit, guys, so that we can see what we are given here. So that's question 1.1. We are given to evaluate or to find the integral of 2 over the sine of x. I'm just going to quickly rush through this one. So that's sine x tan of x. Then we are given -7 over sine squared x, all right? Plus we are given 4 pi to the exponent of 3x minus 4 e to the exponent of -4x over 3 plus 1 over the cos of x. All right, then we've got cot x. All right, so that's what we have. Okay, then plus 7 pi over 8. So this is what we're given to integrate the whole of this expression with respect to x. All right, so take note, if you are dealing with integrals, even derivatives, make sure that you write in the simplest form that you can integrate. We can't integrate something of this nature, 2 over sine over tan like that. All right, so let's try to rewrite our expressions. So in this case, we know that if we are to remove these 2, it's the same as we have got 2. Then we remain with something like, in this case, if we remove these 2, then we are going to remain with 1 over the sine of x tan of x. All right, so back to your identities. It's not about integration, but identities also. So that's trigonometry. We know that 1 over sine gives us a cosec. All right, so we are going to have a cosec in this case. 1 over tan, it gives us cot. So this is going to be cot x. All right, then we move on to 7 over sine squared. Remember that 1 over sine, we said it's cosec. So this is going to be negative cosec squared because it's sine squared. So it's going to be cosec squared. All right. On that 4 pi, there's nothing that we can do, just rewrite as it. Take note, we are just rewriting. We are not integrating, guys. We are just rewriting our expression. All right. The same thing on -4e to the exponent of 4x. So there's nothing that we can do there. All right. Then we move on to 1 over cos, 1 over cot. So 1 over cos, that's sec. So you're going to have sec x, then 1 over cot, just like 1 over tan, it gave us cot. So if it is 1 over cot, it is going to give us a tan. So this is going to be tan x. So guys, please revise your trigonometry as much as you can. Okay, that's plus 7 pi over 8 with respect to x. So that's what we had. Or that's what you're going to have in this case. So now we can try to integrate each and every term that we are given in this case. So the first part is 2 cosec x cot x, okay? From your derivatives, you know that if you differentiate a cosec, it is going to give us negative cosec cot, okay? Even from your formula sheet, let me just try and show you here from your formula sheet if I have inserted the formula sheet here. All right, we have got it here. So we have from our integrals, you can see we do not have this integral. So what you do, you go back to the derivatives. These are the derivatives that we have. All right, from our derivatives, there is we need the part that has got cosec and cot, and we've got this part here, cosec cot. So this is the derivative. So we know that the derivative is the reverse that we have of integration, or integration is the reverse of differentiation. So if you integrate from this side, you must obtain what you have from this side. Okay, so if you are to neglect the negative from this side, that means the answer here is going to carry a negative on that side. If you are to put a negative here, then on this side, it is going to be a positive. So the integral of cosec x, cot x, it gives us a minus cosec x. All right, so that is the answer that you're supposed to obtain from that part that we had. So that means if we are obtaining this, this is going to be negative. As we saw, guys, it's a reverse. So it is going to come out with a negative. So that's negative 2 cosec of x. Okay, so that's cosec x. Then we move on to cos squared x. All right. We have the integral of that cos. Oh, that was cos or cosec. Okay, that's cosec. 7 over sine. We said cosec. I don't know how I ended up writing like this. This is cosec squared. All right. So we have got cosec squared x. All right. So sorry for that, guys. So what do we have on the integral of cosec squared? Okay, that one we get back again to our formula sheet if you have some challenges. All right, from this part, we can see that we need to part with cosec squared. All right, this is where we have our cosec on the derivatives. If you differentiate cot, you obtain negative cosec squared. So that means if you integrate a positive cosec squared x, it is going to give us a negative cot on that side because you have neglected the negative. So this is going to carry a negative. But if you integrate with a negative, then cot is going to be a positive. I hope we understand the reverse part that is happening there. So which means our answer must be a negative. So we shall have this as a negative. Sorry for that. All right. So we shall have this as a negative here. So already there is a negative on our cos, on our cosec already there's a negative. So negative and negative is going to be a positive. So that will be positive 7 cot x. Remember, it's the reverse, which is cot. Okay. Then we move on to the integral of 4 pi. So take note, I listed this before. I told you guys if you are given the integral of ka to the exponent of f of x like this with respect to x, your answer is going to be k a to the exponent of f of x, all right? Everything over the first derivative with respect to x ln a. So this is the formula that you're supposed to know. So in this case, if we are to check properly here, we can see that we've got our k here. This is our k, and our f of x, that's our 3x. And a is represented by what? Pi. So this is the same expression that we have. So from our answer, we said this is going to be ka to the, which means it's a repetition of what we have, which is 4 pi to the exponent of 3x. Everything over the first derivative with respect to x. And this is our f of x. So if you differentiate 3x, that is going to be 3. Ln a, which is our a, it's pi. So it's going to be ln pi. Okay, so that's what you're going to have. So guys, know your derivatives also, because this applies or this works together with the derivatives. Do not just revise. If you just revise, you say, I'm just revising integration only. There's nothing like that. You have to revise also differentiation. Okay. So if we were to check, that's the same formality that we have on the other part here. It has got E, but it's the same format that we have. So in this case, our answer was supposed to be like this. Let's just write it aside, then we can take our answer here. So our answer, like we said, it's ka to the, which means our k in this case, that's the constant part that we have here of 3. We have got this with a 3. So it is going to be negative. So it's going to repeat as it is, okay, for that case. So it's negative 4 e to the exponent of negative 4x like that, everything over that 3, because it's a constant, okay. But in the denominator here, we need the first derivative with respect to x. And with respect to x, this is our f of x. So the first derivative of negative 4x, that's a negative 4. So we're going to multiply to negative 4. Then ln of a, of which our a in this case, it's e, the base. So it is going to be ln of E like this. Okay, so we know that ln E is a 1, or you can just leave it like that as ln E, but here we can cancel. As we can see, we have got -4 and -4, so these two can cancel. So our answer is going to be a positive, so that's positive e to the exponent of -4x over 3, or you can write it as 3 ln E. It's one and the same thing, or you can just write it as E, just one and the same thing. Okay, that's it. We move on to sec-tan. Okay, do we have this in our formula sheet, direct sec-tan, or we have to take it from our derivatives? That's what you need to check. All right, so let's see here. We can see that we do not have from our integrals, we do not have sec-tan. But if we are to check on our derivatives there, if you differentiate sec x here, you obtain sec-tan. And I told you that this is just a reverse. So if you integrate sec x tan x with respect to x, your answer is going to be a sec x. All right, so that's it. Our answer there is going to be a sec x. So let's see here. All right, so we are going to have plus, all right, okay, sorry for that. So this is going to be a plus sec x. So we're going to have plus sec x in this case. The last part is a 7 pi over 8, which is representing a constant. All right, so that's a constant. And know that the integral of a constant with respect to x is going to give us ax plus the constant of integration. So a representing the constant. So in this case, our constant is 7 pi over 8. You just have to multiply by what? By x. Then we add the constant of integration. So that was the integral of the whole part that we were given. So I just hope we saw the stages properly that we are supposed to apply in this case in order to obtain the final answer that we have here. Okay, so that was question 1.1 on integration. We move on to question 1.2 with 5 marks. Simplify and integrate. So take note, it's simplify, then after simplifying, integrate. So let's see what are we supposed to do in this case. So take note, the question paper that we had, if you check in your memo there were so many errors which were there. So we just want to figure out these errors as we are revising, and please take note, revise much as you can as you prepare for your exams. It's very, very important. Okay, so this is the integral of, that's 1,2. So let's take this, that's 1,2. I think I've moved so much. Okay, like this. So 1,2, we are given to evaluate this integral of 7 cos. So that was 7 cos x plus that's sine x, okay, plus 9 everything over cos squared. Okay, so let's check again if it is truly that. So that's 7 cos x according to this, that's cos x sine x, okay, but we can't like integrate direct this part. Okay, so what can we do, guys? We have to integrate with respect to x. All right, these are two terms. 7 cos x sine x is a single term. 9 is a single term. So we've got two terms in the numerator. So applying the concept that I already talked about, a plus b over c, I told you guys, is the same as a over c plus b over c. You can separate these as long it is under the same denominator. So that means from this integral, we can have the integral of 7 cos of x, then we have got sine of x, everything over cos squared x, plus 9 over the cos squared of x, as long this is the same. All right, so that is what you're going to have in this case. We integrate this with respect to x. All right, we can simplify here. We can note that we have got cos x here and we've got cos squared there. We've got 1 and here there are 2. So we're going to remain with 1 of the cos x. And we know that sine over cos from our identities, that's a tan. So we're going to have the integral of 7 tan of x plus, okay, we talked about this previously, as long it is cos in the denominator, 1 over cos, that is supposed to be a sec, but here it's cos squared. So it is going to be 9 sec squared x. All right, so this is what you're supposed to integrate with respect to x. All right, so let's see if we can integrate this part. Can we integrate tan? Is it possible to integrate tan? Yes, it's possible. We know that the integral of tan, this one you're also given in your formula sheet. It gives us ln sec x plus the constant of integration. So this is going to be 7 because it's a constant. So that's 7 ln sec of x like this, okay? Then we move on to sec squared. So it's going to be plus 9. What is the integral of sec squared? So if you have to check in your formula sheet, also we do not have this sec squared. So we are going to take it from the derivatives. Okay, I think I explained this before. So from your derivatives, we have sec squared. Yes, we've got the part that gave us sec squared. If you differentiate tan, you obtain sec squared. This is your y dx. So the opposite now, if you integrate sec squared with respect to x, your answer is going to be a tan. So in this case, we are going to have our answer carrying a tan. Okay, so sorry for that. Okay, so we are going to have our answer as 9 tan x. All right, so that's 9 tan of x plus the constant of integration. So that was it, guys. Just to simplify, then we integrate as much as we can from the information that we have. So these were the proper stages that we could have taken to integrate this typical question. All right, so as you can see, it's more of identities there. All right, on 1.31, sketch and clearly indicate the area. Take note, you're indicating the area that is enclosed by the graph of y is equal to 2e to the exponent of x, and the x-axis and the coordinate or the ordinate of x is equal to 1, and x is equivalent to that's -1 and a 1. Also show the representative strip to calculate the area, and that's 4 marks. Okay, so let's see what you're going to have. So this part is your, guys, you must know from your mathematics N3, you are sketching these graphs. Okay, so that's 1.31. We are given to sketch the graph of y is equal to 2e to the exponent of x. So all you just need to know, guys, how do you sketch an exponential function, or if you're given a to the exponent of f of x, if it is like that. If it is a positive, then we are going to have our shape like this. All right, we are going to have our shape like this, where this point represents your a. All right, so that's the shape that you're going to have in this case. So in this case, we are given y2e to the x is just the same format that we have a to the x is just 2. So 2 is just a number multiplying. So that's where it is going to pass through. Okay, so it's supposed to be k here, and this point is your a. Sorry for that. This is your k, not a, but a k. All right, so in this case, we are going to have our sketch. All right, let's just have our sketch here. So we are going to have our y-axis versus the x-axis here. So that's our x-axis and our y-axis there. So as you can see, we are having the same shape, just like that one. So we are going to have our graph tending to reach the x-axis, then it goes up. All right, so please know these graphs, guys. Okay, just find time to just revise your mathematics N3 on how to sketch graphs. So this is the graph that we have of y is equal to 2e to the exponent of x, and the y-intercept at this point, it's at a condition where x is equal to 0. Okay, sorry for that. And we know that when x is equal to 0, we are going to have, if x is equal to 0 here, that's e to the exponent of 0, which is 1. So it's 2 times 1, which is 2. So it's going to pass at 2. Like what I said here, k is the value that you have here, which is k. So here it was 2. So here it's going to be 2. All right. And we are told that this graph is supposed to be bounded between the curve, okay, the x-axis, and we are given some ordinates to work with, or some values for x to work with, where x is -1 and a +1. So we can assume that we have -1. Take note, negative is actually on the left side. So let's say this is where we have -1. This is where we have +1. So the region where we are going to have our area is between the -1 from this side and the +1 from this side. So this is where we are supposed to be calculating our area in this region. Okay, so that's it. And the representative strip, you just indicate it's with respect to x. As you can see, it's between the curve and the x-axis. So we've got a representative strip for the x. So that was the curve or the graph that we are given to draw or to just sketch. Okay, then on 1.32, we are now asked to calculate using integration. I've talked about this, that integration is used to calculate the area. Okay, so that's the magnitude of the area indicated in 1.31, that is 1.31 way from that graph that we talked about. So from this graph, can we calculate the area? So like I was saying, this is where our area is calculated from -1 up to +1. And I referred this, I always refer these guys, please understand your area is equivalent to the integral with respect to x of f of x. So our area with respect to x, that's the integral of f of x with respect to x with the limits a and b. So this f of x is simply y, so it's like this, y dx like that. That's the formula for area. All right, so that means in this case, our f of x, which is y is equal to 2e to the exponent of what? X. And the limits taken from the point of -1, which is our a, and the +1, which is your b. So that means we can have our area. So take note, we said our f of x is 2e to the exponent of f of x. So that means our area is going to be in the integral of 2e to the exponent of x with respect to x. And we said the limits are taken at a and b. A is -1, which is the lower limit, b, the upper limit at +1. So that's the limit there, -1 and +1. So it's you guys to integrate. We integrated e previously. Remember, guys, we integrated this e previously from that integral of k a to the exponent of f of x, where we said it's going to give us k a to the exponent of f of x over the first derivative with respect to x ln of a. So if you are to check here, this is the same format. So you're going to have 2e to the exponent of f of x over the first derivative with respect to x, of which we've got 1x. So if we differentiate 1x, that's a 1 times ln of a is the base, of which our base is e. And ln e, guys, ln e is 1, or you can just write as ln e, but ln e, guys, is 1. So we are going to have 2e to the exponent of x over 1 times 1, which is 1, which is 2e to the exponent. So it's just going to repeat as it is. So that's the integral that you're going to obtain. That's 2e to the exponent of x. But remember your limits from -1 up to +1. So therefore, the numerical value is going to be the area when you substitute the values that you're given, the upper limit minus the lower limit. That's 2e. In place of x, we substitute 1 minus the lower limit, which is 2e. In place of x, you substitute -1. So that is going to be the area in this case. So simplifying from our calculator, we are going to obtain something like 4,7008 something. Okay, let me just show the screen so that we can see the calculator here. All right, so what we see now, everything on the screen. So that's our calculator there. So let's see our calculator. Okay, it's coming. We just have to insert these values. Okay, so that's 2e, that's shift. We've got e here to the exponent of 1 minus 2, shift again, ln there, which is to the exponent of -1. So you're going to obtain something like this. So to 3 decimal places, that is going to be 1, 2, 3. So 8 is going to change this 0 into 1. Okay, let me indicate it here. Put 1, 2, 3. So 8 is going to change this number here, which is going to give us a 1. So that is going to be 4,701. So this is area measured in square units, or you can write a square units in words, but that's what you're having for the area. So guys, take note of the stages or the steps that you're supposed to take when you are calculating the area enclosed by a certain region that you're given using the integration method. All right, so that was the question on integration from the question paper of August 2021, Mathematics N4 from Meson African Motives. Till we meet again.